So let's begin with seeing how to manage geographical data and how they can be represented in the context of a system for geographical information representation. And the main things that we're going to see would be the vectorial data and the raster type of data. So let's begin with the vectorial data. And these are some examples. The main would be the polygons, the line type, and the dot type of data. This will be geometric information. There are different standards on how they are represented and how this information can be used and how to create relationships between one and the others and how to convert them from a polygon and extract the lines, which would be the border, the boundaries here. So this is the vectorial data in general terms. So generally speaking, the simplest thing would be a vertex. So one point has one vertex, a line has two or more, and a polygon has three or more. And normally these are closed polygons. So finally they're in the same point. These are the main characteristics of the geometries that we use to represent this data. So these are the limits of the municipalities in Chiapas. This is where we are working, and it's represented as a polygon since it has a defined area. This example of the lines could be the streets, the roads, or could be a power line, or some other things that can be represented with lines. In some cases, you will be able to see rivers represented as lines or probably as polygons. And the points or dots are very common when data is collected. So when data is connected from the GPS, every second it can generate a point. And this is an example. When you want to represent a parcel or a location, a point is what you most commonly see. So this is vectorial data. Another important point about these type of data is that they not only include the geometry, which is the spatial portion, but it also holds a part that's non-spatial. It's a table. This is an attribute table. And this table has all the other non-spatial columns that we would have in a data frame in R, for example, or in Excel, or in other types of data representation system for tables. So I can send this information from different models. I can visualize it as a table, just like in an Excel spreadsheet, and I can edit information here if I enable the option. But there are other options available where I can visualize, like for example, like a form. And this is easier to edit. And there are many other things that you can do here. So generally speaking, everything that can be done in Excel or in R can also be done with these tables. So I got different tools for attributing colors, do color coding based on the values. I can filter, I can create a new column based on the others. So all this can be done in these tables, with the main advantage is that these tables are linked to the geometries. So I can see the information spatially, but also I can see it in tables. And the modifications that are done in one or the other are synchronized. When you wish to represent these elements, let's say that you have a geometry where you can see the points on the map, but I use information from the attribute table to determine which symbols or which colors I would like to use to prepare the map. So this is the best way to convey the information that's stored in the table, to show it in a more visual way, more practical way. So for example, this is how to configure symbology. And depending on the type of geometry that I have, it's going to show me the different options. If you want to use a line, a polygon, or point, and I can configure everything else. For example, what's the color that I want to for the inside of the municipality, for the exterior, if I want to have a transparency, or what else I want to do. For points, I can configure the size of the point. Depending on the size of the point, this could determine the size of the attribute. So there's many things that can be done, and that we're going to see in the practical part of this module. Another example on how to do this dialogue of expressions, as we saw before in the R software with the deep layer package, the mutate function that we saw before, well, we can use it here with a more graphical interface, more friendly. So you can create a new column based on the one that already exists. And you can even use Python programming in this one. So everything's possible. Not everything is simple, but everything can be done. You can have access to more references and details in this link. Another important item, or something else that you can do with the vectorial data, and also with the raster type of data afterwards, is to do this function of identifying the different entities. So wherever I click, it's going to show me all the information that you have in the attribute table, like a form of the different information that's available about this point. I can also use the information as a label. I can show on the polygon one of those pieces of information that I'm interested in. So this is what we're going to see mostly. As I said in the beginning, there's so many things that you can do here, but since R can do many of these things too, we are probably going to be using R more for organizing data, to analyze the statistics, etc. You can automate things in R, and you can do all of those things with more flexibility and control. But in QGIS, we are going to use more visualization tools to prepare maps with the information that we have available. Another type of commonly used tool with vectorial data would be selecting spatial objects. So you can select objects with different methods, for example, a polygon or a line. You can also select not only with the geometry, but you can also select it based on the attributes. So you can use an expression very similar to what was done in R with the filter option, for example. You can even click in each one of the rows that you would like to select. So there are many available tools to do this.